Pay close attention because in this video, I'm going to work through 3 problems like this in detail, which are about parallel lines cut by a transversal. Let's start with the one I have here, which is the simplest, and little by little we'll make it more complicated. Look, here we have that line M, and line L are parallel, and here we have a transversal represented by the letter S. They're telling me that the measure of this angle is 5x plus 10 degrees, and the measure of this angle over here is 2x plus 70 degrees also in degrees. Would you agree with me that the measure of this angle is the same as the measure of this angle? Why? Well, because they are corresponding angles, so I can set up the following. Look, I'm going to write that 5x plus 10 is equal to 2x plus 70. And now, let me solve for x in the equation. What do I have left? I'm going to move the x terms to the left side, so I'll leave 5x here, and I'll bring this 2x over as minus 2x now on the left side. On the right side, we have a 70. And this plus 10, we'll move it to the right side as minus 10. Let's do the subtraction. 5x minus 2x equals 3x, and 70 minus 10 equals 60. Finally, we can divide by 3, so we get 60 over 3, right? Well, 60 divided by 3, and 60 divided by 3 is equal to 20. All right, we already have the value of x, but we need to find the measure of this angle and this angle, which, by the way, we had already said should give us exactly the same result. So once we find the value of x, we're going to substitute it here. So we have 5x. In this case, I put 5 times 20 because I already found out that x is 20 and we're going to add 10. We do the operation. 5 times 20 is 100 plus 10 equals 110. There we go. We have it. So the measure of this angle I have here is 110 degrees. Let me write it like this. Now let's find the measure of this angle, which should give me the same result, right? All right. But let's substitute anyway to verify. It's 2 times x plus 70, but x is equal to 20. So I get 2 times 20 plus 70. 2 times 20 is 40, and 40 plus 70 equals 110. And in this case, it's degrees. As you can see, in fact, we're getting exactly the same result. If we hadn't gotten the same result, does that simply mean we solved the equation incorrectly? But in this case, since we are getting the same value, it means what we did was correct. That's it, we're done. Exercise number 1 is that simple. Let's make it more complicated. This exercise might seem much more difficult, but it's actually done exactly the same way. Look, here. Even though we have a lot of information, we have to focus on the data they're giving us and, obviously, on what they're asking us for. In this case, once again, we have to calculate the measure of this angle and this other angle over here. But before I focus directly, I am going to explain what this means over here. It says here A, B, and it has a little line on top. This is read as segment AB, this is read as parallel to, and this is read as segment DC. So, what I'm saying here is that segment AB is parallel to segment CD. Let's locate the segments. Here we have segment AB, and it's telling you that it's parallel to segment CD. Now, this is how I read it. Let's say that segment AB is perpendicular, that is, perpendicular, which forms a 90-degree angle. That's why this angle here is marked with segment AI. So, does that mean that these two are forming a 90-degree angle, and that these two are parallel? Now then, I ask you, which one will be the transversal in this case? Well, it's going to be exactly this one right here, right? This transversal that we have over here. So, I want you to see that this information I have here, I mean this and also this line, is actually unnecessary. I'm just showing them to you, because many times you might come across diagrams like this that seem much more complicated, but in the end, as you can see, it's exactly the same thing. Because if I cover this, I realize that we have 2 parallel lines cut by a transversal. So now, let's look at the relationship between these 2 angles we have over here. I want you to notice that the measure of this angle is the same as the measure of this angle. Why is that? Well, because they are alternate interior angles, right? In fact, in the previous video, I already talked about that classification. So indeed, this angle and this angle have the same measure because they are alternate interior angles. So, what do I have to do? Well, I set this angle equal to this angle. There, I've got it right here. Let me leave the left side of the equation as it is for now because I'm going to work it out. Here it is. 5 times x is equal to 5x. Then 5 times 20 is equal to 100. And over here, we have a minus 20. We do this subtraction. For now, I keep copying everything I have on the left side. And well, I'm also going to copy the 5x. I do the subtraction. 100 minus 20 is equal to 80. I move everything with x to the left side. So I have 8x minus 5x. It's equal to 80, which is already on the right side. And we're going to move this 92 as a minus 92. We do the subtraction. 8x minus 5x is equal to 3x. And on the right side, we have 80 minus 92. This would be minus 12, right? So finally, we're going to divide by this 3. So we get that x is equal to minus 12 divided by 3. And minus 12 divided by 3 is equal to minus 4. All right. Now we have the value of x that makes this equation true. Therefore, if I want to find out how much this angle measures, I just need to substitute a minus 4 here, right? If I want to find this angle's measure, I just plug in minus 4 here. Let's calculate the angle. It should give the same result. Let's go. So I have 8 times x plus 92. Let's write it as 8 times x, which is minus 4 plus 92. Let's do the calculation. 8 times minus 4, that's minus 32, and minus 32 plus 92. Well, that's 92 minus 32, which is 60, right? In this case, it will be degrees. All right, I'll write it here right away. We already have that. This angle measures 60 degrees. All right, let's move on to the next one. So we write 5 times x plus 20, but x turned out to be minus 4. So it would be minus 4 plus 20, and then it's minus 20. We do these operations. 5 times minus 4 plus 20. Well, it's the same as 5 times minus 4 plus 20, which is 16. So I'll have 5 times 16 and then minus 20. We do the operation. 5 times 16 is 80. Minus 20 is 60. All right. As you can see, we're actually getting exactly the same result. And that had to happen, right? Why? Because that's what we agreed on, right? That this is the transversal. So if these two lines are parallel, then these two angles are alternate interior angles, so they have the same measure. Let's finish with exercise number 3. Again, we have two parallel lines, and, as you can see, this would be the transversal we're interested in, right? So, this little piece here, this line segment, really isn't even necessary, because like this, we already have two parallel lines cut by a transversal. Now let's look at the relationships. As you can see, notice that this angle is greater than 90 degrees. Right? Can you see it? And this angle is less than 90 degrees. So definitely, those don't measure the same, so now we don't have to set them equal. Right, we don't have to do that now. What could we observe? Look, for example, I can observe that this angle right here, this one here, could be, for example, alternate exterior to this one here. See, we have two parallel lines cut by the transversal. So this angle is an alternate exterior angle with this one over here, right? Therefore, this angle right here would also have to measure 15. So let me write it down. Look, this one and this one are alternate exterior angles. Now why am I moving it over here? Well, so that it fits correctly now. It's very logical that if I add the measure of this angle to the measure of this other angle, it has to give me 180 degrees. Right? That is, these two angles are supplementary. Therefore, I could state the following. We can write 3i plus 15y, since it has to give me 180 degrees, because these two are forming a straight angle. And now, let's solve for y here. So, 3y plus 15y's gives me a total of 18r's. And on the right side, we have 180. All right, I'm going to leave out the degrees for now, okay? We're going to divide by this 18, so in the end, we have 180 over 18. And well, that's equal to 10. All right, now we have the value of y. so we just substitute it in. But we can do it directly here, since they're specifically asking us about this angle. So if I do 15 times y, then I would have 15 times whatever its value is. And in this case, it's 10. And 15 times 10 is equal to 150. Now, let's add degrees. There you go. We already have that. This angle measures 150 degrees. Now let's move on to this one, another one. It says that this one measures 3i. So in this case, 3 times 10. And 3 times 10 is 30. There you go. So this other angle measures 30 degrees. And as you can see, it worked out, right? Since 150 plus 30 does equal 180. In this case, degrees, and that's it. We're done. If you liked this video, please subscribe to this channel. I'm uploading videos every day. See you next time. Take care and behave yourselves. Oh, and please never forget that math has your back. See you next time. Bye-bye.